Hi everybody, my name is Imran Kazri and I'm going to be talking about the Softeam solution for the INCOSE challenge in this particular video. So let's get started. Well, we all know that the initial INCOSE challenge was related to the formation of a centralized entity called PERC to manage the different departmental operational centers or DOCs in a country called Forestia. So now, here is what we are addressing in this particular solution. We basically handle requirements, structural and behavioral modeling, allocations, parametrics, concurrent engineering, systems and subsystem modeling, document generation, traceability, impact analysis, and some additional features such as business process modeling. So here we see the global scenario that we basically focus on in our particular solution. So here you see that we have a central entity called PERC, which basically communicates with external actors such as media, the general public, the national weather system, the civil and military aviation authorities, the different docks, which are themselves communicating with firefighters, water bombers to get real-time status and additional aspects such as fire apparatus. So now we turn towards Modelio, our modeling environment, to see how this particular solution is being implemented. So now you see here that we are in our modeling environment and we see different windows such as the diagram window, the model explorer window, the outline window, and some additional tabs which represent the different features in our modeling environment. So one of the important things that you'll see here is the diagram explorer window that enables you to see all the diagrams present in your project. Normally, in any other modeling environments, these diagrams are spread throughout the Model Explorer window, and it's sometimes difficult for a designer to see where that a particular diagram, such as a state machine, is placed in the hierarchy of the Model Explorer. So, for example, I want to find a sequence diagram which details the interaction between the PERC and a rotorcraft manufacturer. And so I can either go through the Model Explorer and then see the hierarchy. So here I'm going through the different packages and seeing, okay, there's a particular sequence here that says negotiations restarted scenario or the PERC rotorcraft manufacturer scenario. Or I can also go through the diagram window and see a selected particular diagram. So here you see the list of all the diagrams present in my project, and this Explorer window can also be sorted out depending on different options. So I can either see the flat view that you already saw. Diagrams can be sorted by diagram types, by user folders, or by context window. So let's now get started with our initial modeling. Now, normally the requirements are either written by an end user using a third-party tool such as Doors or Microsoft Excel form. So here in this particular solution, what we did is that the initial requirements were written in a third-party tool, for example in our Excel, and then these requirements were imported in Modelio using our Excel Exchange module. So here you see that we already basically imported these requirements, and they're also available in graphical or tabular format. Now let's turn to the requirements diagram, which details all the different requirements which are also written, and we see the different dependencies and see how these requirements are either refined or being satisfied. So let's turn to the diagram view and let's select the global requirements for the PERC. So here what you see here is the global window which shows the different requirements, the dependencies, the requirements being refined by some use case, and also they are being satisfied by additional blocks. Now these are additional steps that normally follow the initial requirements, but since here we see the global picture of the requirements, so you see all the different dependencies as well. So here the green level requirement is the top level requirement, and then we have the requirements in orange which show the other end user requirements, and then we have some requirements written in blue which basically determine the different other end user requirements that we deemed suitable for the completion of our particular solution. And then you see that we have the different blocks which are basically satisfying these requirements, and then we have some one use case which particularly refines the top level requirement. So once you have defined these initial requirements, let's carry on with the additional modeling. So now let's turn to the global operations, and now we select it in our particular Explorer window, and we see how it's being refined. So we can see that it's related to a block diagram, but first, before moving on to that, let's check out the use cases diagram, and we see that we have different use cases related to our global scenario. We have some requirements which are being traced, and then we see in this particular example a particular use case where the PERC is communicating with the air rotorcraft manufacturer to specify the air rotorcraft specifications. For example, that they should have a minimum cruise speed of 965 km per hour and some particular salvo capacity as well. Now let's turn back and go to our global operations, and then let's check out its related block diagram. So now what you see here is the block structure of the PERC. So the PERC consists of different subsystems such as a power system, a DCI interface, a PERC operation center, a national fire data center, an alert management system, a national fire incident reporting system, and a central communication and dispatch center. So what are the functions of these subsystems? Well, the central communications or dispatch center enables communication between the PERC and other subsystems and the external environment. The alert management system basically gets alerts from, for example, the media or the National Weather Service, and assesses the level of the alert, the priority of the alert. The National Fire Data Center basically is a database management center. It consists of a database and a database management system, and basically stores the real-time data of the different firefighters and the water bombers. The PERC Operations Center is in fact the heart of the PERC, and it basically carries out the resource allocation. The DCI interface is in fact enabling the PERC to communicate with the dock that are present outside or are seen as an external environment. The power system basically provides power to different subsystems. The National Fire Incident Reporting Center basically stores reports from the different firefighters once a particular firefighting scenario has been carried out, and the firefighters report, or the water bombers basically report fire incident reports detailing the causality damages, the cost, and the potential impact to the resources present in the docks and to the PERC. And then now once we have defined the different subblocks, let's go check out the internal block diagram of the PERC itself. So let's select the PERC and then see the internal block diagram. So here in the internal block diagram, what we see here is the internal compositional structure of the block. So here you can see the different sub-blocks. They are communicating with each other using communication interfaces. For example, here in this particular case, a TCP/IP. They are also allocated, and we'll talk about it a little bit later on. And we see initially also the National Fire Data Center, which consists of a database management system and a central database. Also, the DCI interface is of particular importance because one of the initial requirements was that the DCI interface is supposed to be changed later on when the PERC and the dock are established completely. So this is an initial interface which may be refined or changed later on. So here you see a dedicated communication interface, and in also the common TCP/IP interface that enables the DCI interface to communicate with the internal environment. So one of the things that we can do is enable concurrent engineering. So for example, let's say that this DCI interface is supposed to be changed later on. So how can we do concurrent engineering or IP reuse? Well, what we can do is define this DCI interface as a third-party block. So here you see that in this particular case, we already had the DCI interface defined as a third party off-the-shelf component. Now, here you see in this particular model explorer this particular icon, which shows you that this model was in fact created by an external party, and then it was imported in our project and then used to create the particular DCI block and its instance in the composition of the perk itself. Now, suppose that we change the DCI interface later on. What we just need to do is basically deploy a model. So here you see a deploy a model component, and we can deploy a package model component defined by a third party in another scenario, for example using Modelio, of course, and then we can import this model and then reuse that particular model in our perk composition. So this gives an example of IP reuse or concurrent engineering in our particular application. So now let's check out the activities of the perk itself. One of the initial requirement was that we had to define what is the initial operation of the perk, and then we had also defined the different modes of the perk itself. Now see the global activities of the perk itself. So here we see different activities related to the perk and related to different subsystems of the perk itself. So we basically see some initial communication going in. This communication is being rerouted. So depending upon the type of communication, if it's an alert, it goes to the alert management system, which basically determines the type of alert and then sends that information back to the perk itself. If it's some fire incident report, then it goes to the National Fire Incident Reporting Center, and then also this information is rerouted and placed in the database of the Fire Data Center. Initially, if some requirement related to the power operation, then that particular scenario is handled. Similarly, the communications goes to the perk itself, and the perk has two main operations. So it basically carries out allocation and coordination activities, and it also enables to communicate with the air rotorcraft manufacturer. So here, for example, you see here that we can say, okay, this particular action behavioral node calls the air rotorcraft manufacturer scenario that we were talking about initially. So here you see the perk communicating with the air rotorcraft manufacturer. So basically it sends some specification. This specification is then acknowledged, and the perk carries out some internal operations. It then sends a feasibility report to the perk, which then carries out a feasibility report evaluation scenario. Now we have two options here. For example, either the feasibility report is accepted or it isn't. So if the feasibility report is approved, then the perk sends some acknowledgement and the aircraft manufacturer begins production. If the report is not approved, then it does some internal reporting and begins renegotiation, and then some renegotiations are restarted, which we don't go into this particular scenario. Now, let's go inside the perk itself and check out the different modes of the perk. This was one of the initial requirements of the INCOSE challenge, that the perk itself was supposed to consist of three global modes. A green mode where at the low risk level, for example in case of winter where there's no more really big chance of wildfires. The amber mode where you know that a fire may start soon, so all the different firefighting equipments and the firefighters are being readied. And red mode where you're in the crisis mode and where you're actually doing the firefighting itself. So here we see a state machine showing the different modes of the perk itself, and what you see here is the related diagram also in the graphical model, but let's relate it to the red mode activity, but we'll go into that a little bit later on. So let's check out the green mode activity, which basically shows the perk in normal weather conditions. So here we basically state that the perk checks its alert status and then does some normal resource and training management if there is no alert level. It basically carries out some maintenance of the firefighting equipment if it's needed and train firefighters and manage their holidays and duty schedule. In case of an alert being received, then it basically switches to Ember mode. Now, we won't go into the Ember mode itself, but we'll go and check out the activity of the red mode. Now, let's check out that particular activity. Now, one thing you'll notice here is that this red mode activity isn't depicted using a systemal notation, but in fact, this particular activity is defined using the business processing modeling notation. So this is one of the other things that we can carry out in Modelio, is that we can link different standards via the related node diagram option. So here we see that the perk is communicating with the dogs. And in case of firefighting scenario where the actual firefighting is being carried out, does some initial allocation and communicates information to the dock for firefighting coordination. Now, what happens is once it sends that information and the dock begins firefighting, there are two cases which can happen. For example, either the dock requests some backup and then asks the perk to reallocate the resources and do the coordination, or it reports to the dock that the different firefighting equipment have been thoroughly utilized. The firefighters have finished firefighting in the particular location and the fire has been finished. So this is related to that particular red mode activity. Now, what we can show you here is some allocation diagram. So here we already saw the DBMS before in the internal block diagram, and we see here that using concurrent engineering we can make use of hyperuse again. So here we basically specified that we are going to be using a DBMS software. For example, in this particular case we are saying okay, we are going to be using Oracle, and we basically allocate this particular software to the database management system. Now imagine if one day we don't use Oracle or we use another database software, for example SQL, so we can just create that DBMS software either in our particular project or defined by third party, and then we can import that module and then redo the allocation. So that's one more thing related to concurrent engineering. Now, we are nearly finished with all the different diagrams. Now let's just look at the timeline of our particular scenario. So here we see that the docs are informed of the change in organizational structure, and then we carry out different aspects related to this particular scenario, such as the establishment of the dock, the interface establishment between the perk and the docs, and the transmission of control from docs to perk for the resource coordination and the final testing and integration. Now, what I can show you more is the ability of Modelio to create automatic diagrams. Now that's something that's really interesting, is that it enables a designer to create automatic diagrams. Now, for example, here I say, let me create a dependency diagram of the perk. Now what it does is automatically generates some diagrams, and here you see the different blocks or concepts which the perk depends on for its whole composition. So example, here I'm seeing the perk, and you see the different blocks which are in pink. So here this diagram shows that the perk block depends on these additional blocks for its composition. But you see also that we have some blocks in yellow. So basically what it shows is that these blocks were basically created outside our project and they were imported. So basically it shows that this is basically hyper reuse. So these this DCI interface were created externally, and then was used to create the composition of the perk. Similarly, the DECCOM interface is also something that is present in the component model outside. So you see here the DECCOM interface. Similarly, what I can show is an impact analysis, which is the reverse of the dependency diagram. The dependency diagram basically tells you what elements are used for the creation of this particular block. The impact analysis is the reverse, and it just shows you that what is the difference if I remove the perk, what is the impact on the model. So here in this particular case, we see that the perk depends on is basically influencing some internal behavior. So maybe that's not a particular good scenario. So what we'll do is look into the perk and see its internal structure. Now this is the National Fire Data Center that I told you about regarding the database management system. So let's check out the impact diagram for the National Fire Data Center. So here we see that if I change the National Fire Data Center, it will influence other blocks in my diagram as well. So what we can see here is that we can do some impact analysis and say, okay, if I change the National Fire Data Center, all these particular modeling concepts present in the perk will be affected. Similarly, for the database software, we saw that there was an allocation, and we say, yeah, that basically it depends on a dependency link which is related to the allocation itself. Another aspect that is of particular importance is the aspect related to traceability. So we have here a particular option here called the link editor. Now here what I'm just going to show now is the traceability window. So here you see the perk. Now let me just lock on it so we don't change it later. And now we can change the different levels of hierarchy, the downstream and the upstream dependency levels. So here, let me just say go here now. Here you see that the different dependencies the perk is using to link with other modeling environments. For example, the perk is related to a state machine diagram, an internal block diagram, and is satisfying some particular initial requirements. Now I can also go more in detail, and here you see that okay, this particular requirement that was being satisfied by the doc is also being derived by an upper high level requirement. Similarly, I can go back and see how the dependencies in a downstream manner. So here I can say, okay, this impact diagram depends on the perk itself. This is the impact diagram that we generated just later on. So here, what you can really see is a level of traceability between the different modeling concepts present in our project. So here I can go more in detail and give you a more detailed complete picture. So let's end up with the link editor. Another thing we see here is the notion of document generation. So in this particular case, it is possible for us to generate documentation. So what we can do is generate some documentation depending upon the end user requirements. So here what we did is we created some documentations. The documentation can be either in HTML, OpenXML, or D format, and additional information can be added, such as table of contents, table of figures, revision table. So, and then we can do out the document generation. So I won't go into the document generation aspect, but what I will show you is another feature which is really more interesting is the web designer aspect. So what I can do is I can create a web model, use the web model publisher, and generate some documentation. Now this documentation is a little bit different as compared to the initial document publisher module that you saw later on, which was static in nature, and this one is dynamic. So here let me just write some detail for the document, the generation of the document, and let's just say okay, like I want to create some documentation and I say, okay, let's just generate the documentation. Now it will momentarily, in a few seconds, generate the documentation, which you'll see is in fact an HTML view of the model hierarchy. So instead, you can either you can have some static documents, or you can have some nice HTML documentation which shows you the dynamic structure of your model. So here I can browse through all my model and the different diagrams. For example, I say, okay, I want to go see the timeline, and I see the timeline itself. Similarly, I can see the different other aspects, such as the actors. I can browse through the perk. I can say, oh yeah, that was the initial impact diagram that I just created before. So this particular view is really useful because it enables to send models in HTML form to people who are not particularly using this particular modeling environment, or they don't have access to the particular software. They can just get that HTML file, go through the model, explore the model, see the different diagrams, and then report their feedback. So that's really one more interesting feature for our particular scenario. So what else? Well, we can do a lot more stuff, but in this particular case, I think we'll just leave it at that. And if you have any additional queries, please send mail to me at my email address. I have already written there.